as promised, here's some examples of transforming some exponential functions. Okay, so I've written down 6 problems here that we can do. And just a quick reminder that here's the form for transformations. The a value is the base of the exponent, and it tells us how steep the curve of the graph is going to be. The h is moving the entire graph to the right or left, and then the k is moving the entire graph up or down. And then if we throw negatives in there, a negative x would make it reflect over the y-axis, so this direction. And making the a, or the base in front, negative would take the whole graph and reflect it this way over the y-axis, x-axis, sorry. Okay, let's look at this particular problem right here. Y equals 3 to the x plus 2. So instead of just having 3 to the x, which would be a lovely exponential graph right here, we also are adding 2 to that x value, so that's like inside our exponent. That is a horizontal translation that moves the entire graph to the left too. That doesn't affect at all where the asymptote is. The asymptote still remains at 0 because we're simply shifting to the left, so it will still stay there. So our graph would have been, of course, with a point at 0, 1, and then a point at 1, 3. Where did I get that point 1, 3? Well, if I were to plug in a 1 and this wasn't there, it would be 3 to the first power, which is 3. So that's where our graph would normally have gone. But because of the plus 2, we're moving that entire thing to the left 2. So that point will move here, left 2. That point will move here, left 2. And here's our resulting exponential function, more or less. Okay, let's try the next one. This one is a shift downward by 1. So our horizontal asymptote that normally is at 0 is going to shift down to a -1 because of that -1. Now our graph would normally go through the point 0, 1 and the point 1, 2 because 2 to the first power is 2. But because the whole thing is shifting down 1 from there, the point that's normally at 0, 1 will be at 0, 0. The point that would normally be at 1, 2 will be at 1, 1. And then we just follow the curve of our asymptote more or less, and there's our graph, moved down 1. The next one has a negative in front of the 2. That has the result of flipping the entire graph upside down. I've added this 4 on the end, meaning we're going to move the entire graph up 4. Before I put this axis in here, since I have some limited space, I just kind of want to think through what this graph is going to look like. So 2 to the x looks like this. So negative 2 to the x is just flipped upside down like this. And then the entire graph is moved up 4. So if we go ahead and put our axis about there, that's plenty of room. So like I said, our graph would have normally been like at 0, 1 and at 1, 2, so it would be like in here with the asymptote here. And then the negative makes it reflect here, so it's reflecting over the x-axis. But then the plus 4 takes that entire graph and moves it up 4 from where it would be. So that point right there at 0, 1 reflects down to 0, -1. But then plus 4 moves that point up 4 from there. So 1, 2, 3, 4 up to a positive 3. This point normally would have been at a 1, 2, but we reflect it down to 1, -2 and then push it up 4. So 1, 2, 3, 4. So it actually ends up back where it would have been originally. Our asymptote, which would have been at 0, now moves up to 4 because everything's moving up 4. So 1, 2, 3, 4 for the asymptote. I'm going to go ahead and put that in there because that really helps us. And our final graph will be here. So the starting graph is here, the reflected graph is here, and then the reflected graph is moved up 4. Okay, next one we have e to the -x. The e graph would normally be 0, 1, and then over 1 up 2.7-ish. So that's where that graph would be. But then the negative on the x flips it around so it's going this direction instead. So this point stays where it is, but this point will reflect over to this side instead. So our graph will go here with our asymptote at 0 like usual. Okay, number 5. Another graph with E. I've got a couple things going on. We have a left 2 and a down 3. So our normal graph would be here at 0, 2, and then over 1 up 2.7, approximately right there. But then because of the positive 2 here and the negative 3 here, this moves left 2. So I'm just going to take that point and move it left 2, and then that moves down 3. So then that point will move down 3. This point here at 1, 2.7 will move left 2 and down 3. And then our asymptote, which would normally be here at 0, is just going to move down 3. Horizontal moves don't affect the asymptote. So the asymptote at 0 will be down at 3 instead. And if you remember, that point was part of our original problem, not part of this one. So here's what our graph looks like right here. One more. A negative E is going to flip it upside down. The minus 2 moves it to the left 2. To the right 2. Oops, minus 2 to the right 2. And plus 1 moves the whole thing up 1. Okay, so let's look at kind of where our normal graph would have been right here. And then we flip it upside down because of that negative. So something to that effect. And then it moves to the right 2. So this point that was at 0, 1 reflects down to 0, negative 1. Then that same point moves to the right 2 and up 1. Okay? This point that would have been here at 1, 2.7 is now down over 1, down at 2.7. But then that entire point moves right 2, up 1. Remember, this number does not affect the horizontal asymptote, only this one does. So the plus 1 means our horizontal asymptote moves up 1. So there's our guideline for where this is going, and so the entire graph should look something like that, because it's our E graph reflected upside down, moved to the right 2, and then moved up 1. That one gets a little messy.